Today we have the new term laminar flow. We have already discussed the word streamline flow or steady flow. Streamline flow or steady flow of liquid is also called as laminar flow. So velocities of different particles which cross a particular point will be same. So the velocities, flow velocities at different points in the fluid may have different magnitudes, but their directions are same. That means the directions or the streamlines, they are parallel. Such flow we call as laminar flow. So a laminar flow is characterized by parallel lines or parallel stream lines. That's what its characteristic is. Now, opposite type, that means another type of flow is turbulent flow. Turbulent flow, it occurs when the speed of flow of the fluid, it crosses a limiting value called critical speed. So, high speed liquid flow, they are almost turbulent flow. Simplest example we can take the case of waterfalls. How the water is falling at waterfalls. The way it falls, it's not a steady flow. That flow we can call it as turbulent flow. Okay, and the streamlines, they are not at all parallel. Okay, so this type of flow, it occurs when fast flowing stream, it encounters rocks. That's what is happening in waterfalls. Small foaming whirlpool like regions called water rapids will be formed. Okay, so that type of flow we call as turbulent flow. And there is the critical speed. That critical speed decides whether the flow is laminar or turbulent. In a turbulent flow, velocity of the fluid at any point in space varies rapidly and randomly with time. We said in laminar flow, at a particular point, the velocity of all the fluid particles will be same. But in the case of turbulent flow, at a point, velocity of the fluid particles will be different. No one can predict. It varies rapidly and randomly with time. So a set of streamlines which are not parallel, which are curved, such sets of streamlines, they show actually the turbulent flow. So this diagram shows a streamline flow which becomes turbulent when it encounters an obstacle in the path. So we have a term called critical speed or critical velocity. So critical velocity, it is the maximum velocity of the liquid up to which the flow becomes streamline. And after that critical speed, if the speed goes above that critical speed, the flow becomes turbulent. Now we have the examples of turbulence. Smoke rising from burning stack of wood. That is an example of turbulence you might have seen. Then oceanic currents, that means the waves also are examples of this turbulent flow. Then twinkling of stars is a result of atmospheric turbulence actually. We know it is because of atmospheric refraction we see the stars twinkling. So it is because of atmospheric turbulence. And the air left by vehicles, that also turbulent, that the path, when we look, we can see that it is turbulent. So these are examples of turbulent flow. Now disadvantages of turbulence: it dissipates kinetic energy usually in the form of heat. So it results, turbulence always results in a loss of energy. Racing cars and planes, they are engineered to precision in order to minimize turbulence. There are some uses of turbulence. Actually, turbulence promotes mixing. The simplest example of this is beating egg. When we make omelette, to mix this egg with the salt properly, we may use beater. So the salt will get mixed with this egg, and when it when it is beaten, no, with beater, actually what is created? Turbulence is created. Okay, that turbulence promotes mixing. In making cake also, in the preparation of batter, we will what beat egg with the sugar and all, so that way that also promotes mixing. So actually turbulence promotes mixing. Then when we add something, that means when we add this sugar to tea also, that time if we use the spoon and all, actually what we are doing, by stirring we are creating turbulence. So turbulence always promotes mixing, and it increases the rates of transfer of mass, momentum and energy. So rate of transfer of mass, momentum and energy will be more in the form of turbulent flow. And the blades of kitchen mixer induce turbulent flow and provide thick milkshakes as well as beat eggs into uniform texture. That's what we discussed now. So this turbulence has got both advantages and disadvantages. Now we have a physical quantity called Reynolds number, which is used to decide whether a liquid flow is laminar or turbulent. So it is a dimensionless number, it has no dimension, and it is given by Re equal to rho Vd by eta, where rho is the density of the fluid, V is the flow speed, that means the speed with which the liquid is flowing, and D is the dimension of the pipe, means diameter of the pipe through which the liquid is flowing, and eta is the coefficient of viscosity of the liquid which is flowing through the pipe. So we have the Reynolds number Re equal to rho Vd by eta. Now how we say what type of flow it is with respect to this Reynolds number? For a laminar or streamline flow, this Reynolds number will be less than 1000. For the flow to be turbulent, Ra should be greater than 2000. So we say flow to be turbulent only if this Reynolds number is greater than 2000. And we say the flow is unsteady. That means it is not streamline or not turbulent, but it is unsteady. The unsteady flow, we say if the Reynolds number lies between 1000 and 2000. So for Reynolds number less than 1000, we have the flow to be laminar, and if it is greater than 2000, the flow is turbulent, and if the value lies between 1000 and 2000, we say the flow is unsteady. And this Reynolds number we use in designing ships, submarines, racing cars, aeroplanes, etc.